Hi there. Today we're going to deal with the concept of refraction. One of the examples that you might be familiar with in everyday life about refraction is the colors of the rainbow. So rainbows are produced either by us using a prism or in nature using water droplets by the bending of white light. And so light, as we know, travels in straight lines, and when it goes through transparent or semi-transparent objects like water or glass, light slows down in these mediums, and light might speed up in other more dense mediums. So how does this work? Well, here's a blown up ray of light, and as it's in a lighter, less dense medium, it travels quicker, and as it goes through a more dense medium with a higher index of refraction, it slows down the light rays. And the boundary between these two mediums causes the light to bend. Here's our normal line again. If you remember when we draw ray diagrams, we can often draw what's called the normal line. That's a line that's 90 degrees from the point where the light hits. And so the change of direction of a ray of light as it passes from one medium into another causes it to change its speed and thus refract. And so we use the term optical density to refer to the speed of light in that medium. When light travels from a less dense to a more dense medium, we know light slows down and the ray is bent towards the normal line. So for example, light slows down when it passes from air into water. So here's air, here's the light ray. As it hits water, cha-ching, it bends towards the normal line. Now don't forget, here's our normal line right here. This angle from the normal line to the ray of light we call the angle of incidence, and this now is called the angle of refraction, not reflection. And what do you notice about these two angles when it goes from a less dense medium to a more dense medium? Well, this little box tells us what will happen. The angle of incidence will be bigger than the angle of refraction. In other words, it will bend towards the normal line. The angle of refraction is smaller because the light, if they were the same, it would go straight if they were the same density. But it doesn't go straight. It bends towards the normal line. Let's look at the opposite. When light travels from a more dense medium to a less dense medium, what happens to the light? It speeds up. And so it'll refract or bend away from the normal line. So let's say light goes from glass to air. So here's our normal line, here's our angle of incidence, and here's our angle of refraction. And what should happen is the angle of refraction now will be bigger than the angle of incidence. In other words, it bends away from the normal line. So this angle is bigger than this angle. We have a number or a figure that we put associated with different substances and what they do to light, and it is called the index of refraction. And as you can see, the table to the left shows different values of substances in regards to how they slow down or speed up light. The larger the index of refraction, the slower light would travel. So, for example, crystal has an index refraction of 2.0, air 1, So crystal would slow light down more than air. Salt, really high. So let's look at it again. Let's say a ray of light comes in to a more dense medium. It's going to slow down, so it bends towards the normal line, which means this is I, the angle of incidence. This is R, the angle of refraction. I here will be bigger than R, and then it leaves the substance, cha-ching. Here's our angle of refraction, R. Here's our angle of incidence. Now R will be bigger than I. Okay, we have medium 1 and medium 2. The ray of light comes in. There's our angle of incidence. Here's our normal line. Here's our angle of refraction. What can we say about medium 1 versus medium 2 given what happened here? Well, is this symbol stands for angle? Is the angle of incidence bigger than the angle of refraction? Is I greater than R in this picture? Yes, yes it is. And so medium 1 would be less dense and medium 2 would be more dense because medium 2, whatever it is, slowed the ray of light down. Okay, let's look at medium 1 and medium 2 again. Here's our angle of incidence. Here's our angle of refraction. Now what do we notice? R is bigger than I. So in this instance, medium 1 would be more dense and medium 2 would be less dense. Less dense. You're going to do an experiment to see how this works. Let's see. What is the relationship between the angle of incidence and angle of refraction? So 41, 31, 50, 35, 70, 45. What do we know about medium 1 versus medium 2? Well, first, look, the angle of incidence is always bigger than the angle of refraction in each of these cases. 50 is bigger than 35, 70 is bigger than 45, 41 is bigger than 31. So when a ray of light moves from a low density medium to a high density medium, the angle of incidence will be higher than the angle of refraction, always. Let's look at this quick clip on refraction.
It passes from air to water, its speed changes. Due to this, there is a change in direction of the ray. This change of direction suffered by a ray of light as it passes obliquely from one optical medium to another optical medium with different optical densities is known as refraction. Note that whenever a ray of light is incident on a surface separating two media, a small fraction of the light always gets reflected. Refraction can make an object appear to be in a different position. For the same reason, the part of the pencil which is submerged looks as if it has moved away from the part above water, and it appears fatter. Now, let's understand the phenomenon of refraction by studying the ray diagrams. Whenever a ray of light is traveling from a rarer medium to a denser medium, the refracted ray bends towards the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I greater than angle R. If the ray of light is traveling from a denser medium to a rarer medium, the refracted ray bends away from the normal. Here, IO is the incident ray, OR is the refracted ray, I is the angle of incidence, and R is the angle of refraction. In this case, angle I less than angle R. For definitions, click on the labels. The ray of light striking the surface of separation of
Hopefully that gives you a good idea about how things are bent or refracted.